Hello, and thank you for your great question. So for this question, it says to write a molecular equation for the gas evolution reaction that occurs when you mix aqueous hydrobromic acid and aqueous potassium sulfite. So this is a great question because number one, it's a practice on writing formula when given compound names. It's also great in terms of writing gas evolution reactions. Oh, that should be spelt incorrectly, sorry about that. Gas evolution reactions, and it's also great because it involves balancing an equation. So we're going to need for this to look at three different tables. You'll need your polyatomic table, which I don't have here, but that is in your textbook on page, let's see, 143. You are also going to need this one at the top, which is types of compounds that undergo gas evolution reactions on page 227. And lastly, you'll need your solubility rules, and that's found on page 219. So, back to our question. The first thing, that I'm going to do is I'm going to write a formula for hydrobromic acid, and I'm also going to write a formula for potassium sulfite. So I should have added that you will also need on page 152, how to write formula for acids. So first of all, hydrobromic acid is a binary acid with two elements, and how I know that is that binary acids start with the word hydro. So that's going to be hydrogen, which has a charge of +1, and bromine, which has a charge of -1. And then if I do the cross-down method, it would be a 1-to-1 ratio, but I don't have to write that. And it says that it's aqueous, so I can put AQ here to identify that. Next, I have potassium sulfate, and potassium is in group 1 on my periodic table, so it's going to be a +1. And sulfite, when I look it up on my polyatomic table, has a formula of SO3, and it has a charge of -2. So when I do the crossover method, it means I'm going to have 2 potassiums for every 1 sulfite. And this is also aqueous, as shown by, as it says right in the question. Now, next step is to figure out what my product will be. And for this, I'm going to need to go to, my types of compounds that undergo gas evolution reactions. And I'm going to look at this, sulfites and bisulfites, because, just to bring it back, I do have potassium sulfite in my reaction side. So I'm going to look at sulfites, and it follows the pattern of H2O being produced and SO2 in gas form being produced. So I can do that. I can start off my product side with SO, and it has to be a 2, so we lose an oxygen, cleaves off, or SO3 decomposes into SO2, and this is the gas. So there's the gas reaction part of it. And then lastly, it's going to be my potassium and my bromine coming together. So it's going to be KBr, and it's going to be, I have a +1 as my charge on K and a -1 on bromine, so that means they're going to come together in a 1-to-1 ratio. And I have to figure out if this is going to be aqueous or if it's going to be a solid. So for that, I need to use my solubility rules, and I see that I have K right here, and which means that it's soluble and there are no exceptions. And then I'll check for bromine, is also soluble, but the exception is when it's paired with Ag, Hg, or Pb, and it's not, it's paired with K, so that means that KBr is soluble. So when I go back here, I can put that because it's soluble, it's going to be an aqueous form. So now I have my skeleton equation, and I now need to balance it. So over on my reactant side, I have potassium, I have bromine. I'm going to separate the sulfur and the oxygen because, as you can see, they don't stay together. Well, it doesn't repeat itself over here. It goes from SO3 to SO2, so that means I do break them up. And then I have hydrogen. And that's going to be the same over on this side. On the reactant side, I have 2 potassium, I have 1 bromine, I have 1 sulfur, I have 3 oxygens, and I have 1 hydrogen. On my product side, I have 1 potassium, 1 bromine, I have 1 sulfur, I have 3 oxygen, and I have 2 hydrogen. I'm going to balance my potassium first, which means putting a 2 over on this side. So I get 2 potassium and 2 bromine. And then I'm going to put a 2 over on this side to balance my bromine on this side. And that's going to change it to 2 hydrogen. And now all of my elements balance out. And I've balanced my equation. So that's how you complete this type of question. It is complex because there's a lot to do in this. You have to first get the right compound formulas using the charges. You then need to know what the pattern is for a gas evolution reaction involving sulfites. And then you need to know your solubility rules, and then you need to balance. But I hope this helps. Practice makes perfect, and it's a great question for bringing all of your skills together in units 2 and 3. Thanks for watching. Bye for now.